NASA engineers have re-established communication with the Voyager 1 spacecraft, Earth's most distant emissary, after months of troubleshooting a glitch that had rendered the probe's transmissions unreadable. Could the Voyager spacecraft be disclosing new and terrifying revelations from the depths of space? Originally intended for a mission lasting only 5 years, NASA's Voyager probes exceeded expectations and continued their trek across undiscovered parts of the cosmos for nearly 45 years. Recently, Voyager 1 has communicated some confounding data back to Earth, confusing astronomers. In this video, we'll investigate these fascinating finds and the surprising insights they potentially hold. Voyager 1 was launched into space on September 5, 1977, from Cape Canaveral, Florida, using a Titan III Centaur rocket. This was the beginning of an incredible adventure. On August 20, 1977, only 15 days earlier, Voyager 2 had already set off on its space exploration journey. The primary mission assigned to these twin spacecraft was initially to explore Jupiter and Saturn, the gas giants in our solar system, as well as their moons. But these daring adventurers went much beyond what they had planned to do, setting off on a voyage that would take them to the farthest corners of our heavenly neighborhood. Voyagers 1 and 2 have broken many records during their historic mission. Having outlasted every previous spacecraft in history, they have flown farther from Earth than any other human-made object in interstellar space. These are the first objects created by humans from their exploration of portions of the galaxy that are yet unknown to science and beyond the influence of the Sun. Scientists have gathered an immense amount of priceless data from these groundbreaking interstellar probes, which are located more than 12 billion kilometers from Earth. Their discoveries never cease to astound physicists. We'll talk more about one amazing and unanticipated discovery later on that scientists could never have imagined. The twin probes of Voyager have accomplished amazing things throughout the years. Over 40 years ago, they made the astonishing discovery that there were moons on Jupiter and Saturn, shocking scientists and upending their preconceived assumptions about these far-off planets. These moons turned out to be throbbing with geological activity, defying earlier theories that they would be dead and cratered like our own moon. Particularly during its voyage, Voyager 2 accomplished a number of noteworthy milestones. As the first spacecraft to sail past Uranus, it made history in 1986. It was the sole spacecraft to fly past Neptune, having done so 3 years later. From Neptune's ferocious winds and icy volcanoes on Triton to the hitherto undiscovered moons of Uranus, this amazing voyage provided a plethora of knowledge about these far-off ice giants. NASA has implemented multiple procedures aimed at extending the spacecraft's operating lifespan while it continues its amazing voyage. By turning off heaters and non-essential parts to save energy, the spaceship will continue to operate far beyond the next 10 years, since the Voyager mission is planned to conclude in 2030. This meticulous management guarantees that they will be able to continue returning data as long as possible. For the scientists and engineers who have been involved in this amazing journey from the beginning, the Voyager mission's end is a moment of mixed emotions. A mission far more successful than anyone could have imagined has resulted from their commitment and tenacity. Many scientific advances and significant new understandings of our solar system and beyond have resulted from the data that the Voyagers brought back. Future generations of scientists and space enthusiasts have also been inspired by them beyond our wildest expectations. Before their launch, the Voyagers experienced and captured the wonders of our solar system. These missions have revolutionized our knowledge of these celestial worlds, revealing secrets like the frozen shell of Europa, the towering volcanic plumes on Io, one of Jupiter's moons, and the amazing discovery of Jupiter's thin rings. Previously believed to be lifeless and desolate, the amazing pictures and data they returned showed lively and active worlds. New questions emerged as Voyager 2 traveled farther and encountered Neptune and Uranus, highlighting the richness and complexity of our solar system's outer planets. The finding of 10 hitherto undiscovered moons around Uranus and the harsh weather on Neptune, where winds might reach 1,000 miles per hour with surface temperatures down to -391 degrees Fahrenheit, -235 degrees Celsius, were particularly notable. Triton, the biggest moon of Neptune, was discovered to be among the solar system's coldest locations. Other surprising discoveries included the ice volcanoes of Triton, which released frozen particles and nitrogen gas. As Voyager 2 carried on its extensive exploration of the outer planets, Voyager 1's trajectory brought it dangerously close to Saturn's moon Titan, exposing its hazy orange atmosphere and intricate chemistry. Many new concerns concerning the nature of these far-off worlds were raised by each encounter, which yielded a plethora of data that challenged preconceived notions. Ordinary spacecraft were not what Voyager 1 and Voyager 2 were. Their precise design called for them to be stable platforms, rotating at a rate that is over 15 times slower than a clock-hour hand. Because of its design, there was less visual blur as the spaceship was speeding through space and taking pictures and data. Even before they encountered the outer planets, their astounding imaging skills started to amaze scientists and the general public. While still several months away from Jupiter, the spacecraft began to transmit photographs of the planet. The gas giant's whirling clouds and recognizable Great Red Spot were seen in these early photos, which thrilled viewers at NASA's Jet Propulsion Laboratory. But the real catalyst for the Voyager's groundbreaking observations was the finding of active volcanoes on Jupiter's moon Io. It was discovered that Io, a moon that is marginally bigger than Earth, is the solar system's most volcanically active body. Our knowledge of these far-off planets has changed as a result of the Voyager research of their moons and outer planets. The astounding discovery that Europa, the moon of Jupiter, may have an ocean beneath its frozen surface sparked curiosity about the possibility of extraterrestrial life. Similar to this, the finding of geysers flowing from Enceladus, the moon of Saturn, indicated the possibility of liquid water beneath the surface of the planet. These results have motivated follow-up missions to learn more about these fascinating moons and have significant implications for the hunt for extraterrestrial life. The experiences that Voyager 2 had with Neptune and Uranus were equally revolutionary. During the probe's approach to Uranus, it was discovered that the featureless blue-green planet had many moons, including the fascinatingly active Miranda and a complicated magnetic field. Humanity received its first detailed photographs of Neptune in 1989 when Voyager 2 passed close to the planet, revealing its vibrant atmosphere, deep blue color, and great dark spot. In addition, the spacecraft confirmed that there are weak rings surrounding the planet and found 6 additional moons. The Voyager's equipment continued to send back important scientific data as they traveled farther into space. Crucial data regarding the heliosphere, the bubble-shaped area of space dominated by the Sun's magnetic field and solar wind, was supplied by the probe. The Voyagers were able to investigate the interstellar medium, the sparse environment between the stars, after passing through the heliopause, which marks the edge of the heliosphere. The unexpected rise in cosmic rays found in interstellar space is one of the most astonishing recent findings from the Voyager probes. This discovery has caused scientists to reconsider their theories about the interstellar medium and the environment beyond our solar system. The information gathered by the Voyagers on magnetic fields, plasma waves, and cosmic rays is still very helpful in understanding the composition of interstellar space and the mechanisms forming our galaxy. The longevity and success of the Voyager missions are a testament to the creativity and dedication of the scientists, engineers, and technicians who designed, built, and operated the spacecraft. The Voyagers have persevered in operating despite the extreme conditions and great distances they have traveled, returning data that has revolutionized our knowledge of the solar system and beyond. The missions have also brought attention to how critical robotic exploration is to advancing our understanding of the cosmos. NASA has put policies in place to preserve the Voyagers' remaining energy and prolong their missions as long as feasible as they get closer to the conclusion of their operational lives. The spacecraft are anticipated to survive until at least 2030 if they carefully manage their energy supplies and shut off non-essential systems. Our knowledge of the interstellar medium and the outermost regions of the solar system will be considerably enhanced by the data they return during this period. Beyond their contributions to science, the Voyager missions leave behind a lasting legacy. Each spaceship is equipped with the recognizable golden records, which are audio and visual records that showcase the variety of life and civilization on Earth. These documents are a message to any future extraterrestrial civilizations that could come across the spacecraft. The golden record's presence reflects humanity's interest in and desire to establish connections with the larger cosmos. The Voyager spacecraft's breathtaking images confirmed the odd signals picked up from Io. These photos showed a dynamic terrain characterized by towering volcanic plumes and the discharge of volcanic debris. Pele, a well-known volcano on Io, is one of its most spectacular characteristics. Its eruptions have reached heights 30 times higher than those of Mount Everest, erupting across an area about the size of France. More than 33,000 images of Jupiter and its moons were taken by the Voyager spacecraft, demonstrating the grandeur of the planet and the remarkable diversity of moonscapes in the Jovian system. The twin Voyagers have continued to make groundbreaking discoveries ever since they were launched. The discovery that Jupiter had rings was among the most unexpected. These rings, however faint, increased the mystery surrounding the gas giant. In addition, earlier theories concerning these far-off celestial entities were called into question when Voyager 2 discovered that Europa, one of Jupiter's 53 named moons, had an icy crust more than 60 meters thick. This discovery opened up new directions for planetary science research by enticing scientists to look at the possibility of ice moons being habitable. The Voyagers got a vital gravity boost following their mission at Jupiter, which gave them one last push towards Saturn. They would never have been able to break free from the gravitational pull of the Sun and travel farther into space without this essential push. Voyagers 1 and 2 split up soon after, each traveling to uncharted territory. Voyager 1's trajectory brought it very near Titan, the moon of Saturn, which is enveloped in a thick orange atmosphere. Scientists' curiosity over Titan's mysteries led to more research into its intricate composition. After that, Voyager 1 moved north, leaving the planet system and starting its ascent outside of our solar system. On the other side, Voyager 2 set off on an extraordinary journey that brought it to the solar system's outermost planets. It made a landmark flyby of Uranus in 1986, finding 10 moons that were previously undiscovered and thus expanding the number of known satellites on the planet. Voyager 2 arrived at Neptune 3 years later, exposing the amazing features of this far-off ice giant. Voyager 2 reported wind speeds of up to 1,000 miles per hour during its approach with Neptune, the fastest wind yet measured on a solar system planet. Upon approaching Neptune's methane-laden azure atmosphere at a distance of 2,980 miles, the spacecraft offered unparalleled perspectives into this distant planet. It was discovered that Triton, the biggest moon of Neptune, is among the solar system's coldest locations, with surface temperatures falling as low as -391 degrees Fahrenheit. Triton also displayed unusual geological features, such as ice volcanoes that erupted up to 5 kilometers into its thin atmosphere, spitting frozen particles and nitrogen gas. Our knowledge of the variety and complexity of celestial bodies in our solar system, even in its furthest reaches, has increased as a result of these findings. In addition to expanding our understanding of the outer planets and their moons, Voyager 1 and Voyager 2 have contributed priceless data to science. The culmination of the Voyager study of the heliosphere, a huge bubble-shaped area of space where the solar wind is dominant, was the crossing of the heliopause, the point at which interstellar space begins and the solar wind's effect diminishes. Voyager 1 and Voyager 2 became the first artificially created objects to enter interstellar space when they accomplished this feat in 2012 and 2018, respectively. This transition advanced our knowledge of the border between our solar system and the rest of the galaxy by giving scientists a plethora of information on the characteristics of magnetic fields and interstellar plasma. It was discovered that Triton, the biggest moon of Neptune, is among the solar system's coldest locations, with surface temperatures falling as low as -391 degrees Fahrenheit. Triton also had peculiarities, such as ice volcanoes that shot icy particles and nitrogen gas 5 miles into its thin atmosphere. Two notable rings, dubbed Adams and Leverrier in honor of astronomers John Couch Adams and Urbain Le Verrier, who predicted Neptune's location in 1846, were discovered by Voyager 2 after they were verified to exist. Voyager 2 found around 4 ring arcs and 3 more rings surrounding Neptune in addition to Adams and Leverrier. These ring arcs are rock and dust groupings that partially encircle the globe. These arcs do not scatter into space, as one might assume despite their apparent fragility. Their genesis and stability are still a mystery, which adds even more intrigue to Neptune's intricate ring structure. With Neptune, Voyager 2's voyage continued. The spacecraft found 10 new moons orbiting Uranus and offered the first up-close photos of the planet's moons. It also discovered that the magnetic field of Uranus is unusual, oriented away from the planet's core and inclined at a sharp angle relative to its rotating axis. Scientists are more intrigued by the extremely asymmetric and dynamic magnetosphere created by this peculiar magnetic field. Moreover, Triton, Neptune's moon, was discovered during Voyager 2's visit. Nitrogen gas geysers burst from the surface of geologically active Triton. This finding suggested that Triton experienced tidal heating in the same way as Io. These unexpected geysers revealed that Triton had an internal heat source that kept its surface alive despite its extremely cold temperatures. The information gathered by both Voyager spacecraft has had a significant impact on how we comprehend the outer planets and their moons. They offered the first thorough examinations of these far-off worlds, revealing intricate ring systems, active geological processes, and dynamic atmospheres. The findings of the Voyagers have motivated a new generation of scientists and technologists and set the stage for further exploration. According to scientific theory, Neptune's outer ring's gravitational pull confines the arcs and preserves their ring-like structure by exerting inward pulls. Voyager 2 carried on its trip beyond our solar system after its mission at Neptune, following in the footsteps of Voyager 1, which had already entered interstellar space in 2012. This switch was made by Voyager 2 in 2018. The distinction of being the first and only spacecraft to carry out an extensive examination of Uranus belongs to Voyager 2. It found 2 rings surrounding the planet and 10 new moons during its 1986 flyby, but one of these rings, the Zeta Ring, posed a serious conundrum for researchers. The Zeta Ring appeared to evaporate shortly after it was discovered, and it looked to have gone suddenly for over 10 years. Then, in 2022, NASA was able to obtain an upgraded Voyager 2 photograph of Uranus that revealed the elusive Zeta Ring and provided the most precise depiction of the planet to date. The NASA scientists were able to calculate the approximate distance of 37,000 kilometers that separates Uranus from its rings thanks to the new data. The Zeta Ring was intriguingly different from what had been found when it was initially discovered in 1986. NASA's Chief of Observations, Matthew Hedman, observed that the ring has altered dramatically in the last 20 years. NASA's observational equipment now detected a greater signal from the ring. However, the causes of these changes are yet unknown. Is this an instance of planetary development, or may these events be influenced by alien forces? Seasonal variations on Uranus are the main explanation offered by NASA for the Zeta Ring's alteration, which might increase the ring's visibility. The precise mechanics, however, are yet unclear, which adds even more mystery to our comprehension of the outer planets. Over the years, Voyager 1 has also offered important information. Since its launch 45 years ago, it has returned incredible data, making it a valued NASA asset. Following its twin Voyager 2, Voyager 1 entered previously unexplored space. With the spacecraft's extraordinary endurance in mind, NASA launched the Voyager 1 interstellar mission in 1990. Voyager 1 had taken almost 67,000 photos by the time it reached a distance of 6 billion kilometers from the Sun, providing NASA scientists with an abundance of information. Voyager 1's cameras were eventually disabled by NASA to save power, although other types of data were still transmitted by the spacecraft. From Voyager 1, non-visual data is received through the Deep Space Network, DSN, an array of massive radio antennas. The signals are the primary kind of data that are received. In 2012, Voyager 1 left the solar system and reached interstellar space, traveling at 61,197 kilometers per hour away from the Sun. It has since carried on sending NASA useful signals that have shed light on this enormous and mostly uncharted area. Crucial information on the heliopause, the point where the solar wind's effect diminishes and the beginning of the interstellar medium, has been obtained by Voyager 1's voyage into interstellar space. This knowledge has been essential to comprehending the makeup of the interstellar medium. The density, temperature, and pressure of the plasma in this area have been recorded by the spacecraft sensors, providing insights into the characteristics of interstellar space and its interactions with the heliosphere's outermost regions. The voyage of Voyager 2 has been just as life-changing. Its flybys of Neptune and Uranus gave us the first up-close looks at these far-off planets and their moons. Voyager 2 found that the day on Uranus is just 17 hours long, and that hydrogen and helium make up the majority of the planet's atmosphere. The spacecraft also observed Uranus's distinct magnetic field, which is extremely asymmetric and dynamic due to its substantial tilt and offset from the planet's core. Voyager 2 found numerous ring arcs and 5 rings at Neptune. Surprisingly, these arcs are collections of boulders and dust that do not disperse as one might anticipate. Rather, they continue to be grouped, which goes against the accepted wisdom about ring dynamics. Neptune's ring system is mysterious in part because the exact causes of its development and stability are still a mystery. Unprecedented information on Triton, Neptune's biggest moon, was also made available by Voyager 2. It was discovered that Triton is geologically active, as evidenced by the eruption of nitrogen geysers from its surface, suggesting that similar to Io, it is heated by tidal forces. Given Triton's extremely cold temperatures, this discovery was surprising and provided fresh information on the geological processes that may take place on ice worlds. Our knowledge of the outer planets and the larger solar system has substantially increased thanks to the 2 Voyager probes. They have discovered dynamic atmospheres, intricate ring systems, and active geological processes. They keep sending back data as they go farther into interstellar space, expanding the frontiers of human understanding. Long after the Voyager instruments are silent, their legacy will live on. They stand for the persistent spirit of discovery and humanity's thirst for adventure. Their enormous contributions to science have inspired generations of scientists and engineers to aim for the stars and laid the groundwork for upcoming expeditions. Even the world's top scientists are baffled by the increasingly confusing signals from Voyager 1 in recent times. The present broadcast from the spacecraft cannot be decoded, in contrast to the clear data it used to deliver. Data indicating that Voyager 1 is unsure of its position in interstellar space add to this peculiar turn of events. Normally, NASA's Deep Space Network, DSN, would automatically detect this kind of information. One of the many elaborate plans NASA had for the Voyager missions was to outfit Voyager 1 with a unique alarm system that would sound if the probe became lost in space. But despite the jumbled signals, this alarm hasn't gone off. This suggests that although it appears disoriented, the spacecraft has not in fact gotten lost. Additionally, NASA has verified that the antenna on Voyager 1 is operational and continues to be positioned appropriately for communication with Earth. The fact that the spacecraft is still receiving and carrying out directions from NASA suggests that returning data transmission is the issue rather than data reception. Another layer of mystery surrounds Voyager 1 as NASA experts are certain that the signals it sends do not adequately represent its true state in space. At the moment, signals sent to and from Voyager 1 take around 2 days to reach their destination. Given this considerable delay, it is unclear what is going on with Voyager 1 and why the spacecraft's most recent transmissions seem so strange. There are several theories, one of which is the fascinating theory that Voyager may first have come into contact with extraterrestrial life. Like other NASA spacecraft, Voyager 1 is equipped with a unique golden-plated disc called the Golden Record. This DVD includes multilingual audio and video messages, along with a wealth of information about mankind. The purpose of these signals was to alert any extraterrestrials that the spaceship could come into contact with. Though they acknowledge that we have no clue what language, if any, they may speak, the scientists provided many translations to boost the possibility that any aliens might interpret the material. There is yet no solid proof that Voyager 1 has come into contact with extraterrestrial life. Nonetheless, the inexplicable signals it is transmitting could indicate that it has interacted in some way with an unidentified creature. In the past, NASA has overlooked important findings like the galaxies at the end of the cosmos that the James Webb Space Telescope just recently discovered. The idea that Voyager may first have come into contact with alien intelligence, which may be attempting to answer by utilizing the information on the Golden Record, is strengthened by this history of overlooked events. The possibility that aliens are using Voyager 1 to try to make contact with humanity is both exciting and terrifying. It raises a number of concerns over the type of signals being relayed back and the power and purpose of the alien beings. Do they get along? Are they only interested in us? Or are they maybe dangerous? NASA's present efforts are directed at interpreting anomalous signals and determining whether or not Voyager 1's systems have malfunctioned. To ascertain whether the abnormalities are the result of external influences or technological failures, a thorough study of the data is required. Scientists are forced to rely entirely on the signals and data they receive because direct involvement is not feasible due to Voyager 1's great distance from Earth. The fact that Voyager 1 has been passing through a part of space that is mainly unknown to us only serves to complicate matters. Conditions in interstellar space are extremely unlike those in our solar system, making it a hostile place. The spacecraft's instrumentation and data transmission capabilities may be impacted by events it is experiencing that we have never seen before. Exploration and discovery have always been the goals of Voyager 1. It has given priceless information on the outer planets and the furthest reaches of our solar system ever since it was launched. It is currently expanding our understanding as it travels deeper into interstellar space. The enigma surrounding its signals at the moment highlights the inherent unpredictability and shocks of space travel. The Voyager 1 Odyssey continues to demonstrate the tenacity and inventiveness of human engineering. The spacecraft is still an essential source of information even after all these years and the vast distances it has covered. The difficulties it encounters serve as a reminder of the size of the cosmos and the amount of knowledge that remains. Regardless of whether Voyager 1 has found extraterrestrial life, its mission continues to enthrall and motivate us in our pursuit of understanding the universe. Ideas are circulating among those that suggest Voyager 1 is currently under external influence. NASA also takes into account the great distance that Voyager 1 is currently traveling. Voyager 1 is the farthest object created by humans, having traveled a record-breaking 23 billion kilometers beyond Earth. When building its communication systems, NASA did not initially take the potential that the ship might go such a distance into consideration. It is therefore possible that Voyager 1's communication technology was inadequately designed to transmit data across such a great distance. These are only conjectures. Nobody is certain of what is taking place. The actual problem is that the Voyager spacecraft cannot be recalled. Its RTGs, radioisotope thermoelectric generators, must be used until their batteries run out. Voyager 1 is projected to stop operating once the RTGs continue for a further 3 to 5 years. Furthermore, there is no practical means of accessing the spaceship to perform any maintenance or repairs. Voyager 1 took 45 years to reach its current location, making it impossible for any vessel to reach there in that amount of time. All we can do is hope that aliens have not occupied our beloved Voyager 1 and wait for a breakthrough. Maybe in the future, the question of what message the aliens are attempting to relay remains, assuming that they are genuinely sending these signals. The voyage of Voyager 1 and the unanswered questions it raised bring to light the amazing success and constraints of human space travel. The spacecraft's current situation highlights how much more we still need to learn, even though it has yielded priceless data about our solar system and beyond. There are several possible explanations for the signals it is returning, such as technological issues, the great distance, or interactions with unidentified interstellar phenomena. Despite these difficulties, Voyager 1 is still in operation and is returning data that may provide further insight into the workings of space exploration for scientists. Even in its advanced years, the spaceship is still committed to expanding human understanding as part of its original purpose. Though theoretical, the notion of aliens communicating with Voyager 1 sparks curiosity and emphasizes the immense, uncharted territory of space. Any intelligent species that could come across the spaceship, remember to subscribe to our channel and use the like button for more content.